Welcome back. Today, simultaneous equations. This can be done with year 12 knowledge. It just involves a few techniques and a few other bits and pieces from year 12, but it's nothing which is not accessible by a typical AS mathematics student, although the level of difficulty is a little bit hard. The question says to actually show, it's a show question, and let me just write down, show that x is equal to 1 and y is equal to minus 1 is the only solution pair of these equations. And we can actually see now that we wrote the numbers down. Put into the 4 these things, 1 plus 1 is 2 and 1 minus 1 is 2. They work. So we're going to do this with the year 12 knowledge. So year 12 knowledge will say, okay, I'm going to take the second equation, which is the linear equation, and write it as y is equal to the right is equal to x minus 2. And then sub, and we're going to have x to the 4 plus that to the 4 equals 2. You've got to excuse my cough. Oh my God. It's getting worse by the day. Okay, so comes the first technique from year 12, which is just the standard binomial expansion. So this bit here, and the coefficients, I don't know, you can use perhaps a calculator, is 1, 4, 6, 4, 1 from Pascal's triangle. So this, when we expand it, we're going to get x to the 4 plus x to the 4. The coefficient will be a 4 times 2 to the 1, so that's going to be an 8 now. But of course, they will alternate in sign, so it's going to be 8 x cubed. You can show more detail if you want. And then the next coefficient is a 6. It's a plus first of all. And now it's going to be a 2 squared, so it's 24. Next a minus, it's a 4. 2 cubed, 32x. And lastly, plus 16 is equal to 2. Okay, 2x to the 4 minus 8x cubed plus 24x squared minus 32x plus 14 is equal to 0. Half it. So at the moment it's looking fairly standard what we're doing. And although this is given to show that this is, we can actually use it as a little clue. But even if we didn't, the 7 doesn't have many factors. It's plus or minus 1, plus or minus 7. If we put a 1, 1 minus 4 plus 12 minus 16 plus 7 minus 20, and the other one will give you plus 20. So x minus 1 is a factor. So factor theorem could have come into this question. Long division now, or some kind of manipulation. I tend to manipulate it like this. So at the moment, I produced the x to the 4 there with the bracket x to the minus 1, minus x cubed, but I have minus 4x cubed, so minus 3x cubed. But I'm going to write minus 3x squared, x minus 1, there's your minus 3x cubed, plus 3x squared. I need 12, so I need to add 9x squared. I'm going to write 9x, but now there's my 9x squared, and I got a minus 9x, so I need another minus 7. And this terminates, of course, because now the plus 7 balances up perfectly. And then I can factorize the x minus 1, and this will give me an x cubed minus a 3x squared plus a 9x minus 7 is equal to 0. So far, x is equal to 1 is a solution. what do I do with this cubic? On close inspection, -3 and -7 there, -10, 1 plus 9 is 10. So x is equal to 1 is also a factor of the cubic. So basically it'll be repeated. So if you think about it, that's a 1, -3, plus 9, -7, 0. So x minus 1 is a factor of the cubic. So we can repeat the process. X minus, actually let's do it like I've done it before. You can do long division, of course. You don't have to do what I'm doing in there. So we got x minus 1, there's your x cubed, minus x squared. So we now have the -2, lots of x squared, which of course I'm going to write as an x times this bracket. There's your -2x squared, plus 2x. I need 9x, so I need another 7x. And of course, there's my 7x, and the -7 balances. So now I can factorize this bracket from all three terms. So it's going to be x minus 1 all squared, x squared minus 2x plus 7 is equal to 0. And the question finishes, because if you look at this quadratic, b squared minus 4ac is of course 4 minus 4 times 7, which is a negative number. There is no more solutions. This is irreducible, and therefore x is equal to 1, only solution. And of course, it follows from this equation here, y is equal to -1, only solution pair. Okay, so the question has been finished, it's been done efficiently, but I want to show you a different technique, because this was quite nice how it turned out to be, and just get some ideas. So this is now not for year 12 necessarily, and not necessarily a better method for this particular question, but it's worth seeing some vocabulary and spotting some patterns. Now, the first equation, the quartic, is a symmetric equation. Symmetric means basically if you swap, symmetric in x and y. So if you swap x's and y's, it makes no difference. It's exactly the same equation. However, the second equation, the linear, is called antisymmetric. If you swap x and y, so the y goes there and the x goes there, then if you compare it with the original equation, this is actually the negative of the original. When this happens, a set of standard substitutions works, and the substitutions is x. It can be the other way around. It doesn't have to be the x has to be that and the y has to be that, but essentially x is u plus v and y is u minus v. So if we plug these substitutions into the linear equation, we get u plus v minus u minus v is equal to 2. U plus v minus u plus v is equal to 2. The u's cancel. 2v is equal to 2 and v is equal to 1. Careful, because we haven't found x or y, we found v. So let's write it up here. V is equal to 1. Okay, what do I do next? I'll do the same thing now. I'll put these substitutions into the nonlinear, the quartic equation. This is now a little bit unpleasant, but still a little bit binomial. So we got this substitutions is equal to 2. And don't forget, we could put the v is equal to 1 straight away in there, but I think it's probably easier. I don't know if you expand it as it is in there. So I'm going to write it in 2 lines. So that's going to be a u to the 4. Again, the coefficients are 1, 4, 6, 4, 1, plus 4 u cubed v plus 6 u squared v squared plus 4 uv cubed plus v to the 4. And then of course will be equal to 2 when I do this. That's exactly the same, but the signs will alternate. So some terms will cancel and other terms will double up. So that's a minus, and that's now a plus, and it's still equal to 2. These terms now will cancel. So our equation becomes 2u to the 4 plus 12 u squared v squared plus 2v to the 4 is equal to 2. And at this stage probably we can half. So let's make some room. U to the 4 plus 6 u squared v squared plus v to the 4 is equal to 1. Then we can put v is equal to 1, or we could have done it at any stage really. U to the 4, 1 squared is 1, so it's going to be plus 6u squared plus 1 is equal to 1. These ones will cancel, and what we have in there is simply u squared plus 6 is equal to 0. So from this equation we're getting u is equal to 0. Of course, u squared plus 6 can never equal to 0. And we got the two values of u and v, and consequently from here our x is of course adding those two, 1, and our y is of course u, which is 0, minus 1, which of course is minus 1, which is what we got earlier on. This is kind of like a beautiful technique, and this works in this type of equations, particularly if the equation weren't as easy to use elementary techniques. I hope you enjoyed it. I hope you understood what I've done in here. I'll be back with more mathematical videos, and for the time being I'm signing out, and I'll see you very soon. Bye.